Alright guys, so here we go. We're going to look at the review for surface area and volume. So let me get started on this. Number one, if Henry plans to paint the top, front, and side of his shed, which is closest to the surface area that will be painted? So what you got to understand is, for the most part, you don't really want to try to use total or lateral surface area formula because you're being asked to paint very specific things, right? I mean, if you did use total, you'd have to then subtract out two sides. So to me, it really, with rectangles, it just makes sense to realize, all right, you got to find that. You're going to paint that. We're going to treat this as, just a plain side, not like, oh, well, there's a little bit not used because of the door, the hinges, or, whatever. And then, of course, this side, which you can't really see, but that has to be painted. So for each side, for instance, it got cut off a little bit up here, but the top, for instance, is 10 by 12. You see those measurements down. So 10 times 12 is 120. The two sides, 16 by 12, which is 384. That should be times 2. So yeah, 16 times 12 is 192, and then you need that for both sides, right? So times 2, that's 384, and then the front is 16 by 10, so that's 160, and so you just add those all up, as you see right there, 120 plus 160 plus 384, and that's 664. So that's how you go through that. Number 2, Janella's creating a mold to make candles. She wants to make candles in cylindrical shapes with a diameter of 10 centimeters and a height of 20 centimeters. What will be the volume of each candle? Leave in terms of pi. Don't overthink this. Don't make it harder than it needs to be. What will be the volume of each candle? Volume is area of the base times height. Base is a circle. With a diameter of 10, that gives us a radius of 5. The height is 20 centimeters, height is 20. Area of a circle is pi r squared, but we're leaving it in terms of pi, so 5 squared. And then the height is 20, so 5 squared is 25. 25 times 20 is 500. Put the pi in the back. I mean, it's multiple choice, so you won't have to worry about this, but also that would be centimeters cubed. Number 3, if the diameter of a globe is 7, which is closest to the volume of the globe? Again, we're talking diameter at 7, so that actually means your radius is 3.5. And then volume formula for a sphere. Globe is a sphere. Y'all should know that. 4/3 times pi times radius. I know I didn't write it clearly, but cubed. I didn't write that clearly either. These pens. Is that better? 3? Not really. But yeah, it's cubed. It's to the 3rd power. So it's a multiple choice. So if the answer is in terms of pi, you match it. If it's a decimal, you can match it that way. But just in general, you get a decimal out of this even when you put it in terms of pi. And the whole point of using terms of pi is trying to avoid that. So I turned it into a fraction, improper, even though, 343 over 6 is a huge fraction. Again, it keeps decimals out of there. And the minute you round a decimal for pi, it kind of defeats the purpose again. And then just in case, I went ahead also and put the answer here in a decimal. So, it works either way. Number 4, find the volume of the composite. So I showed this pretty clearly. The cube. I know we talk about base times height, because, that's what it is. But, when you're little, I don't know, maybe y'all didn't anymore, but we just said length times width times height, because that's really what you do, right, in a cube. So length times width, and if you want, that's the base, that's the bottom, times the height. That's 8 cubed, which is 512. The pyramid, you are going to have to set up a right triangle. You can kind of see it here in the drawing, but if you go from the center straight down to the middle, make a right triangle out to the edge, and they give you the slant height. So as a right triangle, things aren't connecting. You have 10 there. The top of the cube is the base of the pyramid. So on the bottom, if you go from the middle to the edge, that's 4. That's why over here I have 10 squared minus 4 squared in Pythagorean theorem. It's subtracting because you would set up 4 squared plus b squared equals 10 squared, right? And so to solve that, you would subtract, which is that. I believe for my answer, I kept this value in the calculator. So when I did, well, actually it says 1/3 times 64 times 9. But I'm pretty sure that decimal is with the calculator because you wouldn't get 0.523 with only the 1/3 in the fraction. But it's multiple choice. So again, you do the work, you're as close as you can get. I think some people said they got like around 704. And again, I think that's if you do leave it at 9, it's a little bit lower. But again, that just kind of shows in general as you move forward in math, rounding off a value early can affect the answer that much. It just depends on the numbers you're using. Up to number 5. So again, paying attention. Now we're looking for surface area. We had several volume problems in a row there, right? So now surface area of a pyramid. There's the formula right there. It's a square base. Perimeter is 16. Area of the base is 4 times 4, 16. Don't freak out if the perimeter and the base equal the same thing. It happens occasionally. I mean, it shouldn't always happen, but it is possible. And just go through your logic. 4 times is 16, but also as a length times width, base time 4 times 4 is 16. So, it happens. And then the slant height is given to you as 7. So 1/2 perimeter times slant height plus 16 should be 72. Because 16 times 7 is 112. And half of that would be 56. Plus 16 is 72. Centimeters squared, surface area. Again, read carefully, find the lateral surface area. If you saw something like this, a lot of you might think, oh, I don't have the apothem, what am I going to do? Well, you don't need the apothem, because lateral surface area for a prism is simply perimeter times height. So this is a hexagon with all sides at 2. 6 times 2 is 12. The height is the distance between the faces. Again, remember, this prism's on its side, right? This should be a top, for instance, and the bottom or whatever. Bottom. Yeah. So the distance between them would be your height. And 12 times 11 is 132. 7, find the surface area for the following composite solid. So you have a semicircle, or I should say a hemisphere, not a semicircle. A hemisphere and a cylinder. So here at the top I did total for the cylinder, 2 pi RH plus. Now, pay attention right here. We're talking about surface area. If you look on your blue formula chart, total for a cylinder is 2 pi RH plus 2 pi r squared, because the 2 pi r squared at the end covers the base on the bottom, the circle, and the base circle on top. So there's 2 of them. This is a cylinder that's covered by the hemisphere. So surface area being the outside, you don't add both circles in that formula. You take one away. That's why it's pi r squared. So radius is 6, height is 4 for the cylinder. 2 pi RH plus just regular radius squared pi. I didn't multiply pi through in these, of course. So the first part, 2 times 4 is 8. 8 times 6 is 48. 6 squared is 36. 48 plus 36 is 84. That's the cylinder part. And then surface area of a sphere is 4 pi r squared. Since it's a hemisphere, you divide by 2. And I just went ahead and canceled that. So it's like 2 cancels itself out. The 4 becomes 2. 2 times pi times 6 squared. 6 squared is 36 times 2 is 72. So 72 and 84 is 156. If you wanted to get the decimal answer, obviously you would multiply 156 by pi. 156 by pi, which, not using a pi button, but comes out to around 490, 489, depending on how your decimal goes. 8, you have a rectangular prism. The dimensions change as follows. The length triples, the height increases by a factor of 6, and the width is cut by 3. What would happen to the volume? Volume is three-dimensional. We've looked at most problems where everything changes the same. We say the sides doubles. That means the length would double, the width would double, the height would double. This time, though, they kind of, first of all, they're making a different shape now because each thing is changing differently. That's fine. You just take them and multiply them. Length triples, width is cut by a third, height is increased 6 times. You multiply those together. 3 times 1/3 times 6. It happens to leave you 6, so the volume is 6 times bigger. A box measures 10. A box measures 7 wow. A box measures 7 centimeters in width, 14 centimeters in length, and 4 centimeters in height. The height is doubled to 28 centimeters to produce a larger box. Now, there's a slight typo here, we realize, and there's one of 2 ways to do this. Obviously, the height being 4, if you double it, does not give you 28, right? So I just assume, because 28 is double of 14, that we double the length. So you'll notice in what I wrote originally, it says 7, 14, 4, then 7, 28, 4. If you decide to double the height the way it says, and I'll kind of write it over here on the bottom, I'm assuming y'all can see this, that would mean that the width is still 7, the length is 14, so that stays the same, but this becomes 8. Well, no matter what you double, you're doubling one dimension. So if you do 7 times 14 times 8, you still wind up at 784. I don't know what happened to that 4 at the end. It just got away from me. Wow. Anyways, the point being, doesn't matter which one you double. There was a typo, so either it should say the height is doubled to 8 or the width is doubled to 28 centimeters. Either way, though, doubling one dimension will simply multiply the area by 2 or the volume by 2 because everything else stayed the same. So this answer is still correct. The second volume is twice as big. All right, on to the second page, and let's finish this up. All right, let me set this up. Use the similar prisms to find the surface area of B. All right, so they give you side lengths and then the surface area of the bigger one. If you set up a scale factor of 16 to 12, that's the comparison of the sides, and you see that here. But since we're talking about surface area, we always say you have to square scale factor for area. So we're going to set up a proportion, but it's not just 16 over 12 equals 608 over x. It's 16 squared over 12 squared, because you have to square scale factor. 16 squared is 256, 12 squared is 144, and then 144 times 608 is 87,552. And when you divide that by 256, you get What just happened there? 87552 divided by 256. Yeah, you get 342. That's right. And so the surface area of the smaller one is 342. So again, that's almost half as big, even though 12 is not half of 16. So remember how it affects that. 11, a rectangular solid has a volume of 24 cubic decimeters. If the length, width, and height are all changed to half the original size. So kind of mentioned this before in a previous problem, but notice we're changing all three dimensions the same. They're all being half as big, cut in half. So when we go to set up the problem, now the first question does say, what will be the new surface area? You're not going to be able to get an actual surface area of measurement because, again, just because we know the total volume and it's not a cube, we're not going to be able to find the exact surface area, just how it's affected. So for that part of it, for the surface area part, I even put can't find exact surface area, but it will be 1/4 as big. Because again, surface area, you square the 1/2, 1/4. So whatever the surface area is to begin with, it'll now be as big. What you can find is the volume, because we take that 1/2 scale factor and cube it. That gives you 1/8, and 24 times 1/8 is 3. 12, Bob is painting an open cubical box. He wants to paint the interior of the box, not including the lid. If the box has side measures, this thing is messed up. Sorry. Measuring 15 inches, how much of the surface does he paint? So I try to make a crude little cube here. Not sure how it worked out. Can I make another one? Kind of. So the idea mainly being, though, inside a box, if the box is closed, you would have 6 surfaces. There's the bottom ground, and then there's 4 sides. So that's 5, and then the top. But it says we're not painting the top. So we're going to paint 5 square faces. So all I did is each face is 15 times 15. 225 square inches. There's 5 faces. 5 times 225 is 1,125 inches squared. That's how much surface area Bob is going to have to paint. Okay? And then the last one was another one that had a small mistake. So there's kind of 2 ways to look at it, but the answer, again, should be the same either way. The manufacturer of shaved ice cups made new cones on the left. The radius of the old cone was quadrupled, but the height was not changed. By how much did the volume increase? Now, you have here the fraction 1/2 and 1. And what we should have done is we didn't change the picture. If it's quadrupled, as the problem says, if you keep this as 1/2, this becomes 2, because 1/2 times 4 is 2. If you made this one and quadrupled it, it makes it 4. It doesn't matter either way, to be honest, about how much time it'll increase. The point here to this problem, a radius, even though it's one measurement, just a length, covers 2 dimensions of a circle, because the radius can go in any direction of the circle. It's not just a line in one direction. It can go there, it can go there, it can go there, it can go there. So it covers 2 dimensions. So in a sense, the circle, being the length and the width, are being quadrupled, right? Even though we don't talk about circles as side length and side width, we said it's 2 dimensions. The height stays the same. Well, 4 times 4 is 16, so it's like 2 of the measurements are changing, not the third. 4 times 4 is 16, that's how many times it'll increase, right? So again, when each individual dimension changes, you have to multiply each of those together. All right, hope that helps. Again, the test shouldn't be very long, 10 questions, multiple choice. Do remember the assignment that the sub gave you today needs to be done. Even if you didn't turn it in to him, you can turn it in Thursday. I'll even take it Friday. The point is the grade of your test will be missing or not entered until that assignment is in. Right? I'm not saying it has to be 100. I mean, if you just write random answers, we're going to have a little talk too. But I mean, you had to do the work. That was just all I wanted to get out of it. All right. Also, you should, if you're still in class, you should probably be putting your phones away. All right. So put them up. All right, guys. Have fun. See y'all Thursday. We're almost done with school. Let's get out of here.